So let us discuss the last topic in quantum mechanics. That is just an application of all the quantum phenomena. It is called as tunnel effect. So tunnel effect is useful. Now it is used in it, or rather, tunnel diode works as per tunnel effect. So let us see what tunneling is. We know that when a particle hits a barrier, so here you have a particle, this is a particle is coming, it is having some energy, it hits the barrier. Now according to classical picture, if the energy of particle is less than the energy of the barrier, or if the energy is very less, particle will hit and it will bounce back from the barrier. Now when you think in terms of electric field, if the energy of electron is less than that of the potential field, the electron will be repelled by the electric field. So electron is unable to cross the barrier. So electron repelled by electric field, because the energy of the electron is less than the energy of the field. Electron cannot cross the electric field. Now as per quantum mechanics, we know that electron is having dual nature. So when electron has dual nature, the electron is no more a particle, it will have a wave characteristics as well. Now the electron is found to approach the barrier as a wave, and it encounters the electric field and it tunnels through the electric field, and it reappears as electron on the other side of the barrier and it passes. So though the electron had lesser energy, it is found to cross the barrier. Though, I repeat, though the electron had lesser energy, it do not have enough energy, then also it crossed the barrier, and this is called as tunneling. Now this is also called as quantum mechanical tunneling. So dual nature comes into action here. Electron approach the barrier as a wave, because of dual nature it crosses the barrier and it reappears on the other side of the barrier. So actually it is not a barrier, it's an electric field. Electron approaches a wave, it crosses the electric field and then it reappears on the other side of the electric field. And that is how quantum mechanical tunneling works. Now this is the basis with which tunnel diodes work. So there are three states. First, the particle approaches the barrier, then particle crossing the barrier, and particle leaving the barrier. So particle approaches the barrier, you can see this particle approaching the barrier, particle crossing the barrier. So here the electron encounter the electric field and then it crosses the barrier. This is what is called as quantum mechanical tunneling. Now the particles which is having lesser energy than the potential barrier, they cross, and so it is called as tunneling. So that is tunneling. The chance of penetrating through the barrier decreases as the potential increases. As the potential of the barrier increases, chance of penetrating decreases. So there is another way of reasoning. That way of reasoning says, at the time when this electron reaches barrier, hits the barrier, delta x is 0, or that is a definite position of x. At the time that electron hits the barrier, delta x is 0, definite. That means with uncertainty principle, if you apply delta p is infinity. When delta p is infinity, we know that E is calculated as E is equal to E equal to P square by 2m. So when P is infinity, E is also infinity. So with large energy, when P is infinity, E is very large. So with that idea, we can say that when E is very large, that would have already crossed the barrier. The electron would have already crossed the barrier. That is another way of reasoning. So this process is called as quantum mechanical tunneling, and particle having lesser energy is found to cross the potential barrier because of its dual nature. So with this, we complete our quantum mechanics chapter. Thank you.